Hello there, and welcome back to another CFD cookie with Wolf Dynamics. So this video, it is a continuation, a follow-up of a previous video where we talk about how to open OpenFOAM cases faster, using paraFoam Paraview. I don't want to focus too much into OpenFOAM, so pretty much it will apply to any solver, can be Fluent, CFX, it can be open source like OpenFOAM, just YouTube. So the same rules will apply. So in that video, now we saw that we studied this case, this Cessna case, okay? And in this case, now you should have the OpenFOAM solution, ensight, and BTK solution. And these are your timings. So look at that using the paraFoam, now the plugin that comes, now the tool that comes with Paraview. You decide to, with OpenFOAM, you decide to compile it. It takes 35 seconds for this specific dataset. That is something about 7.8 million cells. Then as you use the option minus built-in, so something that you can use some filters and some specific options to OpenFOAM, it gets faster. And then when you move to the Paraview standalone, like one that you download from the website, from Paraview, from BTK, now it gets much faster. So using binary format, by the way, so I strongly recommend it. It's much faster than the ASCII, but since it gets super fast when you move to a more efficient format like ensight. Okay, so here you see a comparison, ensight version 5.13, Paraview and 6, and see that it's blazing fast, 4 seconds. So we go from 35 seconds to 4 seconds. So we discussed that in that previous video. In this one, I just want to clarify something, how to do this conversion, and then open also the BTK format that I didn't talk about that, I didn't show that. It's pretty much, the speed up will be very equivalent to ensight. For some reason, I prefer ensight format, but feel free to open out to do it also for BTK. I will show you the difference. So in paraFoam, in OpenFOAM, for OpenFOAM users, so this part will be specific for OpenFOAM, but if you're using some other software, you will have the option to save it BTK or ensight, or even TechPlug is equally as efficient as ensight. So basically you will have this command phone to ensight. I'm not going to use it. I already have the conversion there, but just to mention that it runs in parallel. So if you have the case in parallel, use it and you will do the conversion, but it takes many options, minus help. And there you go, you have the option. So see that you have the choice to have it in ASCII, binaries, you want to save sums, you want to save specific patches, and so on. So by default, if you don't give anything, it will save everything, all your patches, the internal mesh in binary format and self-centered data. Then it will be up to you to choose if you want some modifications or other extra options. So usually I save it like that. Okay, but sometimes be careful if you have very large meshes. It's better not to save everything and all the fields. So probably you save some specific fields, the one that you will be interested to work with, but it's up to you. So you will have the data here inside. To point out that if you're using the .org version, if I will recall, anyway, it is .case. This is the file that you need to open with Paraview, or if you are using ensight, that will be even better because it's even faster. This is the file that you need to open. But I think in the .conf it's called .encast. It is the same stuff, nothing changed. Okay, now let me open here just to show you what you will find inside that file. So what you have is this. Now the name of the files, in this case it is a steady case, we have a single file, but if you have on a steady here, the number will change, you will have more time steps and so on. So it's very standard. Okay, also the ensight, the ESI version, the .conf is a little bit different in the format, but it is the same stuff. So this is the ensight format. This is the one I use, the one I recommend. It's very efficient, but then you can go for the BTK format. So the same idea, you will have the tool, and let me click here, phone to BTK. I'm not going to use it. It works in the same way. It works also in parallel and so on. Let me put the minus L, and you will have similar options to those in ensight. Okay, so it will be up to you. If you don't put any options, it will be binary self-centered data, if I will recall. Okay, and then also it will save everything, all your patches, internal patches. Okay, so it's up to you to choose the right option. So, but what I want to show you here, that if you enter into BTK, now you have this. So what you have, all these folders, and in all these folders you have only the information of those surface patches or those surfaces boundaries, okay, that you can visualize. And here you will have the internal mesh. So from this point of view, it might be a little bit more efficient than the ensight, that in ensight probably you need to open everything, but you will have also the option to save specific patches. So if you would like to visualize only, let's say, the body, open just this BTK that is in a small file. And if you have unsteady data, you will have many BTKs there. Or if you need to do operations in the volume and do couplings or isosurfaces, whatever, open this one, okay? So this is the large one, and if you have an unsteady case, you will have many files. So look at that, these are becoming large files, okay? So this is why things are a little bit slower. The same will be with the tech-plot format that, as I mentioned, is equally efficient. You need to compile that plugin. I didn't compile it, but I think it's very straightforward. Probably can prepare a video to show that. And I want to show you, let me open here, and I will launch Paraview. So all my post-processing in OpenFOAM, I do it with the standalone version of Paraview, okay? Everything, all those specific options that you get with paraFoam, you can get it here also using Paraview. You just need to convert the files, that's all. So I will launch it here, and I will open both files just to show you some slight difference and to mention something about as well some operations that you do with the dataset. So let me open first ensight. So as I mentioned, you go for the case. To talk about here, you have all the formats that you can open with Paraview or Paraview 6. Probably you have more format, but as I mentioned, it's way more efficient 6. The developers did a lot of improvement. So let me select all files, and it will be case, and there you go. So okay, so let me close, not to create confusion. So it read all the formats, so I had to select there the specific one, but let me go here, ensight, okay. And it's open, it detected that is the ensight reader. Previously, I needed to select it manually just to save that step. And look at that, immediately I recognize that it's self-centered data, it's reading all my fields. If I click apply, then it will import it. And this is a step that tends to be very slow with paraFoam. So see here, it's very fast. To point out something as well, that sometimes probably the first time that you open Paraview or you open a new terminal, it might be a little bit slower, but then it will be very fast when you open it. I guess it's getting things in cache memory, I don't know, but yeah, it might be the case. No, I'm not saying that always will be that behavior. Something here also that you will realize, look at here that you have this filter, this is the extract block. So when you see this one here, it's not gray out, it's telling you that in this data, you have much information below that. So see that you have all the patches, internal mesh, so you can access that, and I put here, and this will be your prop there, and you get that surface. So this is now how you work with this ensight data. You always need to extract the block, or otherwise, okay, when you apply these filters, now you will get everything. Okay, it can be a little bit confusing when you start to visualize. So that's all, extract blocks, and you select what you want to see. So I will put another one here. I will extract the internal mesh, and now in the internal mesh, I can do some slicing. Let me put this one here, and that's it. Okay, so as you see, very straightforward how to do these operations, and then you can put velocity or whatever you want there, change the scales and so on. So this is the ensight format. Now let's open the BTK format. So it's pretty much the same, nothing changed. You have it here. So now you need to select what you want to see. So let's say that initially I want to see only the body. You select the BTK that correspond only to that surface. This will be blazing fast because it's a surface, and there you go. In this surface, you have all that information, and actually BTK will save node center and cell center, okay? And there you go, you have your pressure and so on. Then if you would like to create a slice and so on, those are operations that are computing on the volume, so you need to load the volume, okay? So if you have on a steady data, you will see many files there, so you can do selection multiple files and so on. So let me open this one that will correspond now to the volume, and this one, okay, will take a little bit more time, but will be as fast as the ensight. So in theory, yeah, you can use that one. So it is up to you which one you use. I feel more comfortable with ensight. I prefer that one, but BTK is equally as fast. Put your slice there, and then you can choose the color, what you want to see there. And that's it. Okay, so this is now, I wanted to mention this. Something that I want to mention as well, that now that you load this data, There are some operations that you have to be careful because they can be a little bit slow. So in particular, now let me create isosurfaces. Isosurfaces is a criterion, and let me put here 0.1. And be careful now that this option here, advanced option, when you activate it, it will give you more options. So by default, this particular filter, it will use now this method, now the uniform binding, okay? This tends to be slow, but I think in this case it will be fast. Now we have this efficient format, but it's better to use OCT3. So be careful with that, and probably if you go open this case using paraFoam and you use this method, you will see that it's super slow, and when you change to this one, things get faster, but still there are operations that can be slow. So let me go here and put this one uniform binding, and basically you will extract now the isosurfaces, and now let me change here to OCT3, apply, and it was much faster, okay? Even here you can see. So be careful that many filters will have these options, okay? Not necessarily will be always the same, but it can be something that it will search like cell centers and so on. So you have some other options that can make things faster. So some people also ask me about that. No, but why the isosurfaces is so slow? So you have these options, and here you have this advanced button now that it will expose more options like this. So there are many filters, so get familiar with them. As I mentioned, sometimes you have those options to do some local search or reconstructions and so on. And yeah, that's all that I wanted to show you, how to speed up your post-processing. So hopefully you found this useful. If you like it, just thumbs up. If you didn't like it, as I always say, I only take positive feedback. But in any case, you have there the comment section. So write all your comments and critics and so on. So thank you, and see you next time. Bye.